So in this video we're gonna study the effect on acceleration due to gravity with the first one that we have is height. अगर हम height increase या decrease करते हैं तो g जो है g उस पर effect क्या होगा height के increase या decrease height with height, that means we are increasing the height. So the first thing is we take on points, that is like we take point A on the surface. This is Earth, its mass is me, and then we have its radius is re, and at point we have 2 points, object at A and the same object at B. This is the radius, that is re, and from A to B the height is h. So the total height that we take from this point, let me take this point to be O, then the height from O to B is gonna be like we take it to be R. Then R would be the sum of h and R is re. This is pretty simple. R is equal to re plus h. Now if we calculate the value of g at the surface of the Earth, you already know the value, but let's calculate it. We are having a formula, g is equals to g me by re square. This is a formula for calculating acceleration due to gravity. Now this formula how it came out to be, let's consider. For this object at A, we have force of attraction by Newton's law. We have g, mass of Earth, mass of the object at A upon the distance between them. And as you know that the force of attraction is obviously given by m into g. Now this is the mass of the object, that means the mass of the object at A. The mass is gonna get cancelled with this, as this is the same, and g we're gonna get is g me upon re square. This is the formula, and we are using this formula here. So at surface, this was something that we calculated at surface. Now so at surface the value of g is this. Now as we move from A to B, like we are not going inside, we're going up from the Earth, from the surface, and we reach a point a point B at a height h from A. Then we have at this point g would be given by capital G into mass of the Earth and the distance between the 2 points. The distance between the 2 points is r, so r square. Then here we have, let's take that the value of g here be g dash, because as we are studying the variation on g by height, so g must get variated, g's value must get changed. So g's value must get changed as we are moving from this point to this point, and that changed value, let us suppose that it's g dash. Then g dash will be given by g into mass of the Earth and the distance between this point and that point, r square. Now we have, if we are to calculate the variation, so for that if we divide this g dash with the g at the surface, let's divide both of them. We'll keep on the value of this g and the value of this g at their appropriate places. After doing so, we'll get g dash upon g equal to re square upon r square. And then as you know that r is equal to re plus h, as you know that r is equal to re plus h, we keep the value of re plus h over here, and we get g dash upon g is equal to re upon re plus h whole squared, because they were squared over here. Then we cross multiply g over here, and as the g goes over here, you get the same. Then you move to the next step and you bring this one up, this one down, and after doing so the power will get a negative sign with it. For example, if you have 2 and its power is 2, and if you're writing it like 2 upon 1, and then the denominator, if you want to change it and make it the numerator, and you want to make the numerator as a denominator, you want to make a 1 upon 2, then the power would become minus 2. That's pretty simple. Here also we are doing the same case. We are making the numerator to be the denominator and the denominator to be the numerator, so the power will get a negative sign with it. Then if you have something on the form x upon a plus y b ax, like something of this form, or something, let's keep it very simple, of this form, then when you open it, it will be a upon a plus b upon a. A upon a will get cancelled, 1 plus b upon a. That's something that is happening over here. We open it, r upon re, a upon a plus h upon re, b upon b. Then re would get cancelled to re, and what will be left over here is 1 plus h upon re. That's same, 1 plus h upon re to the power minus 2, and this is equal to g square, as it was already equal to g dash. So this is going to be equal to g dash. Now as you see that something, you can obviously see here that, as you can obviously see that here we have re is great. Okay, let's come back to this step, and we have g is getting re plus h will be more than re. Then coming back to this point, we know that re plus h is greater than re. That is pretty simple. And you know that here re is less than re plus h. If something is less than something, written x, and then we have x plus y, this result would obviously be less than 1, just because then if the numerator is less than the denominator, the result always is going to be less than 1. And as this is going to be less than 1, its squared also will be less than 1, and it will get multiplied with g. If something is less than 1 and it's multiplied with a quantity, then the quantity gets decreased. This is something important, and this happens every time. So this is less than 1 and it is getting multiplied with g, so g will get decreased obviously, and g dash would be less than g. By following this, we get that g dash would be less than g. So g dash would be less than g, as re upon h, re plus h would be less than 1, as re upon re plus h would be less than 1. So that's pretty simple, and that's all about the effect on gy height.